Hello everyone, welcome back to the channel, and this is the fourth video in the tutorial series for Navigraph charts here on the Aviator channel. Today we'll be covering approaches. Approaches deserves its own video because there's just so many approaches to cover, and having a complete understanding on what the information is being presented to you can differ from each approach, from ILS to NDB, VOR, RNAV, RMP approaches, and so much more. We're just going to skim the surface today and cover what you most likely will use in your sim on a day-to-day use. And in some cases, near the end, where we get into more of the non-procedure approaches like the VOR and the NDB, this is stuff that you might not utilize, but may from time to time run across where you are going into an airfield that only utilizes these type of approaches, and it is your only option to get in. Now today we're going to look at Calgary. And the reason for Calgary is it pretty much has every approach that I need except for an Ndb approach. It's searching for all the airports in Canada. It is one of the few left with a VOR approach, and like I said, it doesn't even have an Ndb approach. And there's a few airports in Canada even with Ndb approaches left into them. So just to try to find it in an airport that works well with this was very difficult, but I think we found a good example and a good place to start here today with Calgary. So we're going to start with kind of one of the most precise approaches, then leading into some of the least precise approaches, which is NDB will be the last one. You can go further, even saying a visual approach is even less than that because you're using your eyeballs out the window. But we're focusing on the approach plates today, so let's move right into what is the ILS approach. So the ILS approach today we're looking at is ILS runway 17 left into Calgary. And nothing really is abnormal about this approach that you might see on other plates, for example, or other ILS plates. There's a few things that I'm going to point out that you have to pay very close attention to that will differ from some airports that have specific procedures and specific ILS approaches. A few that I can think of off the top of my head: London City Airport has a 5.5 degree glide slope. Toronto City Airport, I think, has a 4.2 degree glide slope. So there's things to pay close attention to there. Most time you'll see a standard 3 degree glide slope, but in some cases it does vary slightly, 3.1 to 3.3 degrees. So you just have to take that into consideration because your descent rate will be higher than it would be on a standard 3 degree slope. So let's break down the ILS plate. So the ILS plate is going to give you an outline, or just all approach plates in general are going to give you an outline of what's called the briefing strip. And as you can see here, even Jeppesen has gone far enough to trademark the term briefing strip. The reason why they've done that is it gives you all the relative information that you need to know about the approach right then and there in that box. You should not have to go anywhere else except for getting your ILS or getting your minimums to the bottom of the plate. It can all be found within this briefing strip right here at the top, and everything else is just kind of extra information that you can have. So along the top here, you're going to have all the relative frequencies that you might use on the way in to Calgary in this case. So just to kind of give you an idea on what frequencies you might be using to kind of situationally set yourself up for success. And then in the second row here, you have the information related to the approach itself. So in this case, it's for the ILS runway 17 left, it's localizer identifier India Lima Golf 109.15. The final approach course is 165. Our glide slope crossing fix is Albub at 4890, which is 1,284 feet above the ground. And then your ILS min says refer to the minimums. Airport elevation is 3606, and the touchdown zone elevation, that's what TDZE means, touchdown zone elevation, is 3606 as well. In the box below that, you have your missed approach instructions. So you don't see the airport once you hit minimums. What you're going to do, you're going to climb to 4,100 feet heading 165, then a climbing left turn to 7,000 heading 115, intercept outbound Calgary VOR radio 133 to Ozani. Ozani? I thought I said, yeah, Ozani. Then in the next box below that, the final box on the vertical side here, is altimeter is going to be in inches. If it was in QNH or QFE, it will say QNH or QFE there. Transition level and transition altitude, I stated it in a previous video, it's the same in Canada. So it's flight level 180, 18,000 feet. They're both the same. But once again, if you're in a country that uses a different level or altitude, it will be published and written in those windows there on what it is. So pay very close attention to that. And then it gives you information below of information that is important to the approach or somewhat important to the approach. So you require radar vectors or RNAV capabilities to shoot this approach. Number 2, safe altitude within 100 nautical miles of the airport is 13,800 feet. So that's something to take into consideration. And then also just a side note here, simultaneous approaches authorized with 17 or 8. So they are authorized to shoot approaches side by side with the other runway in this case, which is 17 or 8. Another note, localized reliable within only 10 degrees of centerline. So make sure you note that too, that if you're doing a 30-degree intercept in some cases, that anytime you get outside of that limitation of 10 degrees either side of that localizer, it's not going to be reliable information. You should not trust it. And number 5, a procedure turn is not authorized. This is just a straight-in ILS approach. And the reason why we know it's a straight-in ILS approach is because it's published with a number here, 17 left. In some cases, very rarely for an ILS approach, you'll see it, but it'll say ILS Alpha or ILS Bravo. It will designate that it's not a straight-in approach. But ILSs 99% of the time are straight-in approaches. So just kind of note that. I'll see if I can go find like a VOR Alpha or a VOR Bravo approach and show you what I mean by that. And I actually know an airport that will perfectly work for this later on in the video. Coming down, you have the before we forget, the MSA. So the MSA in this case, minimum safe altitude off is the Calgary VOR, which in this case is over here, just to the east of the airport, southeast of the airport. And it gives you each quadrant. So the northeast 51, southeast 5400, southwest 6100, and northwest of 5800 feet. So the highest sector in this case is to the southwest of 6100 feet. And once again, that's based off the Calgary VOR. So the considerations that they teach us in flight school to make sure of is where is that MSA safe based off of? And in this case, it's the Calgary VOR, which isn't located on the airport. So that's quite a bit of a distance away. So in some cases, this whole ILS approach is going to be conducted within that 5800 sector safe altitude there. But if this VOR approach or this VOR was over, let's say in this quadrant over here, it could technically be in a 5100 safe. So this is where you have to pay careful consideration of the MSA and where it's based off of, because in some cases it's going to be based off the airport. In this case, it's based off of VOR. It might be based off an NDB that's 10 miles away from the airport. So there's special considerations that you have to check to make sure you are not outside of those limitations. Because in this case, you're going to have radar vectors. You're going to be safe to a specific altitude by ATC. But there's some airports, and I can vouch for this in Canada, where you're not talking to anybody and you have to comply with the 100 safe altitude. You have to comply with the sector safe altitude before you're allowed to get lower and lower and lower, before you're able to get onto an approach like this. Because if you don't, you could end up jeopardizing the safety of the aircraft, jeopardizing the safety of the crew and the passengers on board. And that's why it's very important that why they publish these altitudes, you pay very, very close attention to them. Moving on a little bit further down here, you do have the overall diagram of what the approach will look like and what you can expect for waypoint crossing and what could be in your FMS all the way down, or in some cases your GPS. And it'll kind of give you point outs of obstacles as well. That's what these little markings are. You got towers, obstacles, the highest point as well is marked right there, 5,055 feet. So that will mark it for you. And in this case, obstacles are and sectors of this. Actually, let me just round this off without getting too far here. Is the MSA, these altitudes, so this 6,100 feet, that highest sector is going to always be 1,000 feet higher than the highest obstacle in that sector. So in this case, it's 5,100 feet, or 5,100 that would be rounded up to. So you just add 1,000 to that, and that's 6,100. So when in doubt, you just look for the highest obstacle, and you should know if I round that up to 61, or if I round that up to 5,100, then add 1,000 to it. That's what the sector safe is going to be. And there you go. There it is. So that's how they get that information and publish that information. If you'd like to know more information about how they come up with these numbers, let me know. This is really, really advanced, detailed information that I think in some cases it's not even relevant to a simmer on the day-to-day usage of point A to point B flying. But if this is something that you do find intriguing and interesting on how they get these numbers and how they publish these numbers for you to understand, or why you want to understand them, by all means, I will break these down into a little bit more detail later on in another video if you're interested. So you have to let me know in the comments down below. So as we go down the ILS, they draw this nice little box here that tells you at what DME point, what altitude you should be at crossing those DMEs. Just a kind of a good reference. I can tell you from experience in real life, I'm not sitting there going, okay, at 8 miles, I should be at 6150, and I'm looking at my altimeter crossing to 6150 because I should be right on that glide slope anyway. But this is going to give you, the next box down, the horizontal profile, what the approach is going to look like. So if we're flying the ILS approach in this case, we're going to follow the profile of the glide slope, and we're going to comply with the altitudes for that glide slope. So the altitude that will commence the approach at, let's say in this case, is 6,500 feet until glide slope intercept. And then the next altitude we're concerned about is that 4,890 at Albud. And then we're going to fly that down to our minimums, which will either be 3,806 or 3,856, depending if the high intensity runway lighting is out or if it's full. We're going to assume that this is a simulator. High intensity runway lighting is not going to fail just out of nowhere. We're going to comply with, in this case, the full set of lights. And if we are Cat C or D aircraft, we're going to comply with the RVR 2600 or half mile for the approach. That's the best way to know it too. So RVR, I'll break down RVRs for you, which is runway visual range. So you have 2600 RVR, which is pretty standard, which is 2600 feet or a half mile. RVR 5000, which is 1 mile. RVR 1200, which is a quarter of a mile. And then RVR 600, which is 1/8 of a mile. You don't really get much lower than 1/8 of a mile. I can tell you in the airline that I work for in real life, we're only authorized to do 600 RVR takeoffs, so 1/8 of a mile takeoffs. And there's certain parameters that we have to meet to conduct those takeoffs. And we have to have like a takeoff alternate. We have to make sure we have 2 flight directors. There's aircraft requirements, crew requirements, all the other stuff that I think is honestly completely irrelevant to the video that I'm talking with today. So we're just going to move on from that. So the second section here, you'll notice there's these little gray areas here on the ILS approach. These are the localizer step down altitudes. So let's say the glide path or the glide slope is inoperative. So we're only getting localizer readout and we don't have glide slope data. We're going to comply with the gray boxed area altitude restrictions. And the reason for that is now we're in a non-precision approach and we have to figure out, okay, how are we going to step down? How are we going to get down to see the runway? So that's where they comply with these altitudes here, or that's why they put them, and we have to comply with these altitudes. So the first one between Vitki and Upcott down to 5,200 feet, then Albud to Upcott as well, 4,800. And then between Albud and 0.2 DME, we should still have DME readout, of course. It was down to our MDA, which, if I'm going to quiz you guys here, which one do you think it's going to be? Yes, if you said the one on the right here, that is correct. It's because the glide slope is out. So it's a localizer DME approach only. It's down to minimums of 60, which is 454 feet above the ground. And as you can see, requiring the same RVR requirement for if the high intensity lights were out, but if the high intensity lights are out on the localizer approach 2, requiring 1 1/2 to shoot the approach. Now, just dumping down to the box down below here, as you can see, this is where it's going to tell you what the glide path angle is. 3 degrees, so pay very close attention because this is kind of the information on the Jeppesen charts that don't stand out too well. But this is a standard 3-degree glide slope. And this is what descent rate you're looking for at roughly the ground speed. So I think kind of most jets are kind of in the range of 140 to 180-ish knots. So you're looking somewhere in this case, I'd say about 800 to 900 feet a minute is kind of the rough ballpark you're looking for on that 3-degree glide slope descent. You're getting something more than that, you should start questioning things or start looking for things and figure out why is it doing this? Why is it telling me this kind of information that maybe it shouldn't be telling me this? The glide slope might be inaccurate. There is abnormalities that can happen with the glide slope, and you have to pay very close attention to that too. And moving on to the final section of the ILS and the localizer plate here is this little box right over here will tell you what the missed approach instructions were that were just up at the top here. So it's climb out to 4,100 feet, then a turn heading 165, climbing to 7,000 feet, and then a turn heading 110. As you brief here, climb to 4,100 feet, heading 165. There you go. And then it's a left turn, 7,000, heading 110. So if you missed and you're following this all the way down, you're like, what are my missed approach instructions? You need a first glance. There's a glance here, and there's a glance up here. But this will give you the relative information right off the start until you can get yourself cleaned up and get yourself over to a point, in this case, to hold, which is Anoxie. So that was a lot of information. It took me almost 15 minutes to explain just ILS alone. So we're going to breeze through these next little sections a little bit quicker, just because I've covered the overview of the chart and what the understanding is. And now on the next set of plates, it will be a little bit easier to understand the data. So just a brief overview of Cat 2 and Cat 3 approaches in this case. So airports that are authorized for runways that are authorized for Cat 2 and Cat 3 approaches have certain requirements in place. And honestly, this could be covered in a whole separate video, so I'm not going to go into too much detail. But it's essentially the same requirements that we saw before for the actual approach itself. but the minimums are a little bit more restrictive. In some cases, they're not authorized unless prior authorization required from Transport Canada in this case. Governing bodies will put in place requirements for operators to utilize Cat 3 Bravo, Cat 3 Charlie approaches. And in some cases, special crew training, in most cases, special crew training is authorized or is required to get authorization to fly these approaches. So we're not going to cover too much detail there, but if you want to skim over this and see what the differences are, you can flip between the two plates and understand. Once again, this varies from country to country. For most of the places in the world that I know that under ICAO standards, this is pretty standard stuff. Moving into our first non-precision approach, which is the RNAV GNS, Zulu runway 17 left. So very similar information to what we saw before, but we'll notice that the MSA for this one is based off the threshold. MSA runway 17 left. So 25 miles safe is based off the runway threshold, not the Calgary VOR this time. So we'll take that into consideration. So notice how it's slightly higher. It's slightly higher in this case, but that obstacle is still down there at 55. So in this case, they've actually rounded up even more on the erring on the side of caution a little bit more in this case. I'd have to go back and read exactly why they do that for RNAV approaches. I think there is a certain requirement for this, for obstacle clearance for an RNAV approach, because there isn't that reliability quite built into them yet. Don't quote me on that though. As of the time of recording this, I really don't know off the top of my head. There's so much knowledge to know for IFR that some of the stuff slips through the cracks. So I just have to go back and read on that, and hopefully I'll have an answer in the comments section for you guys on that. So in this case, it's going to give you all the relative information that we just saw before. And there's some other additional notes that you have to take into consideration. But the minimums are slightly different. So instead of seeing ILS minimums or localized minimums, you're going to see LPV, LNAV, VNAV, or LNAV. In this case, we see all three. Some of them are just going to be LNAV only. Some of them might be LNAV, VNAV only. Some of them might just be LPV only. And it will publish it as so in the information down below. LPV stands for Localizer Performance with Vertical Guidance. So you're going to have localizer performance, and it gives you vertical guidance all the way down. So it gives you this pseudo glide path, as I like to call it, which is kind of a pre-programmed in glide slope. And what it is essentially it's hard-coded into the airplane that say, if you're this distance from the runway, you need to be at this altitude. And it knows, and it just figures it out all the way down to that minimum, or in this case, what would be a decision altitude of 3806. Now, you'll notice how it's published as a decision altitude. In that case, it's considered a precision approach. But if you move on to this LNAV minimum over here, you notice how it's written as an MDA, a minimum descent altitude of 4060. And that is where it becomes a non-precision approach. So as whole, it is a non-precision approach unless you utilize LPV or LNAV, VNAV minimums, which then makes it a precision approach. And there's even cases where you can only utilize an RNAV approach at an alternate airport and blah, 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 and information that honestly, once again, can be talked about in a different video. But in this case, as you can see, the information presented here can be really, really confusing in some cases. So I have to keep saying this, pay very close attention to the information that's being presented to you on the screen in front of you, and make sure you're dissecting the information the way it's supposed to be dissected. So that's essentially the only difference between the ILS and the RNAV approach. Is this one is GPS based, the other one is traditional based. So the ILS approach has a requirement of ground-based navigational equipment to be used. So in this case, there is a localizer antenna and a glide slope antenna on the ground in Calgary, where this RNAV is all satellite-based or tower-based in some cases, where you're going to be utilizing your position relative to over the earth compared to a piece of equipment on the ground that's sending a beam up to you, which then receives the information, dissects the information, and then presents it to you on your screens. Hopefully that makes sense. Kind of got a little out of control there. Now let's move to even a more restrictive approach, which is, in this case, it would be a precision approach, which is the RNAV RMP, which is Required Navigational Performance, Yankee runway 17 left. Very similar information to what we saw before on the RNAV approach on the last page. But in this case, you've probably seen these arcs and stuff with all these altitude restrictions and stuff crossed on it. If we refer back to the last video where we talked about arrivals, it's very similar. This just carries on to what the arrival was developing and just adding it into the approach phase. And it takes you all the way down to touchdown. It's really well designed and very, very intuitive in some cases where you have to pay very close attention because there's limitations imposed upon the use of these approaches. For the most part, a lot of add-ons in the simulator can utilize these approaches. So by all means, maximize your simming experience by using these approaches. But just take into consideration that authorization is required for these approaches in real life. And there is certain components like aircrew training as well as aircraft requirements to conduct at certain requirements. So required navigational performance, there is a lateral component that is associated with it. And the airplane has to be within a certain accuracy limit to utilize certain minimums. So I know for a fact WestJet, for a majority of their operations, from talking from experience with WestJet pilots, they'll utilize RMP 0.30, but have the capability of using even tighter RMP requirements of 0.10 into specific airports. And there are certain requirements, of course, met for each one, but the compliance is very much the same. They also have a vertical guidance in their operations of 125 feet of vertical deviation. So in this case, we're only seeing the lateral RMP requirements in this case, which is 0.30. But in some cases, airlines have specific operations, in their specific operations, have guidances put in place that they have to comply with that have been approved by the governing body against those approaches. In this case, WestJet is approved for 125 feet vertical deviation either side, which of course makes a lot more sense because there is a vertical component to this approach. Very similar to, like I said, the RNAV on the last one, but in this case, you're following altitude restrictions all the way down until you get past the final approach point, which is Maxon, and then you're following a 3-degree angle, descent angle. It's not a glide path or a glide slope, it's the angle. You're following that down to an angle of an RMP minimum of either 38.59 or 39.51. And as you can note here, in some cases, they're almost as accurate as an ILS approach, but these are far more efficient from a planning perspective and an execution perspective, because the aircraft is allowed to maintain this constant descent from essentially top of descent until touchdown. Very little change has to be made to the aircraft except for configuration of flaps and gear, where a constant power setting can be used all the way down right till touchdown. Moving on to one of the last approaches that we have to cover here for Calgary before we move on to the final approach that we have to talk about, which is Ndb approaches. The VOR approach from runway 26. So VOR approaches, kind of doing away with these all over the world right now. They're becoming more and more obsolete as the time goes along, but there is airports still over the world that utilize this because it's the only capability that they have, where it be ground-based navigation is the only trusted and reliable source compared to space-based navigation, so GPS. And they just don't have the infrastructure in place yet to support the GPS constellation or the other constellations that are involved in developing RNAV approaches. So in this case, we're going to look at the VOR 26, which is the only VOR approach left in Calgary. And as you can see, very similar to what we saw in the Ils Plate, but in this case, it just utilizes MDA of 4100, and it is a straight-in approach because it does utilize a runway number in the actual title. Like I said, I'm going to go pull up an airport here that has a VOR approach that doesn't have a number associated with it, and you'll see that it is not a straight-in approach. It would be marked as a circling approach. So let's go take a look at that really quickly. So I actually just went one step further and pulled up the localizer alpha into Penticton here, because this isn't authorized as a straight-in approach, even though it's almost directly aligned with the airport. Because of where the MDA spits you out at, it spits you out way too high. So right at those minimums there, right where the minimums take place at MDA and the missed approach point, you'd be far too high to be able to be authorized to land straight ahead onto 1/6. So there is certain requirements as well that need to be met for an approach to be straight in. Once again, that could be covered in a more detailed video if there's interest later on down the road. But in this case, you'll notice how it's called the localizer alpha. It's not a straight in approach. and the minimums associated with it circle to land. So as it states, is some sort of maneuvering is going to have to be done once you get to minimums to be able to land successfully at this airport. So whatever set of minimums you hit here in this case, let's say we're flying a Dash 8 and we're flying, it's Cat-C aircraft, we're going to go down minimums of 2720, and we don't see the airport right until that 1.3 DME. Well, we're going to be 1,590 feet above the ground, 1 mile away from the runway. And the airport elevation there is, just judging by this, so what is it, 1,130 feet. So we need to lose, in some cases, we're losing 1,500 some odd feet in a mile. It's not going to happen because our descent rate in that case would have to be in excess of almost 1,900 feet a minute. And that is considered unstable approach criteria for majority of airline operations. So in this case, you'll break out, you'll see the airport, and then you'll visually maneuver or circle the land, as they call it. And in this case, it's going to draw you a little bit of a diagram on where you're going to circle and how you're going to circle. So in this case, you're not going to circle to the right because there's mountains and stuff there. You're going to circle to the left. So you'll just break out, maneuver as required, and land on the airport. In some cases, you might just break off 30 degrees, join the downwind from runway 34, and then come in and join we do the right downwind for 34, and then circle and land on 34 there. I said I was going to find a VOR approach that utilized this, but I knew Penticton off the top of my head had a non-precision approach there because I was just studying this airport not that long ago. So let's jump to our final approach today, which is going to be the Ndb approach, and let's take a quick peek at that one. So the last approach today, we're going to take a look at Kelowna, which is just up the road from Penticton there. We're going to look at the Ndb Bravo, which isn't a straight-in approach yet again. The Ndb Bravo into Kelowna, which, as you can see, very similar outline yet again. Got to remember where that sector safe is based off of. So that 25 safe is based off the Kelowna Beacon, which is, in this case, quite a significant distance from the airport. Almost... was that not 5.9 miles? I think, yeah, 5.9 miles away from the airport. So 6 miles away from the airport. So in this case, you have to pay very close attention to that, because for a 25-mile safe, you're losing almost 6 miles in some cases of protection. And in this case, the southeast quadrant, you're losing almost 6 miles of protection. So just take that into consideration when planning for some of these approaches. But as you can see, this is the Ndb Bravo into Kelowna. Very similar to what we're seeing with previous plates before, but in this case, once again, it's a circle to land, and the minimums applies to all aircraft, all categories of aircraft in this case. But I think that pretty much covers essentially every single approach that we can utilize here in Canada, except for TACAN approaches, which are military based, and I'm not going to go through that because I don't know how to do those approaches myself, and I don't want to give any false information that might not be beneficial to you guys, because that's like falseful teaching, and I don't want to do that. So once again, I think that covers everything today for all the approach plates and all the relative information. The important part was looking at that ILS right at the start there with the approach briefing strip, and taking that into consideration and applying it to all the other approaches here. I just wanted to show you the slight differences and how they can vary from a plate to plate. And I think that covers everything that we need to do, because it made sense to me, and hopefully it makes sense to you. So in the next video, we'll be wrapping this all up with any additional information and additional plates that are in Navigraph charts. And then we're going to conduct a full video in the last and final video from point A to point B, from Toronto to Montreal, and I'll show you how I utilize these plates, and you can kind of see how it's done. So once again, any comments, any questions, or any concerns at all, let me know in the comments section down below. And if you're new here to the channel, make sure you click that subscribe button and click the like button too. And we'll see you guys in the next video.